In the introduction, I said that aviation plays an ever-increasing role in society, and it's nice to have a quick look at how many aircraft are in the air at any given time to give an impression of this huge impact, how aviation connects the world. And for this, I've got a video which shows all the radar-controlled aircraft for a full day worldwide. And here you can see the night passing over Europe, and we see many aircraft flying towards Europe out of the United States. We see them arriving in Europe, and normally if you fly from the United States to Europe, you indeed arrive somewhere in the morning, because over the ocean we do not have complete radar coverage, and therefore there's procedural separation, and that means around noon the order in which the aircraft fly starts to reverse, and we'll see aircraft taking off in Europe, flying over the Atlantic in the westbound direction. You see here also the concentration of air traffic worldwide. United States, Europe, obviously, but also Asia are the three centers of the Earth in terms of aviation. And growth is mainly expected, therefore, in Africa and South America, and further growth in Asia. In the United States and Europe, we have about reached the peak demand for aviation, and except for Eastern Europe, there's not much growth expected there. So how did this all start? This thousands of aircraft that are currently in the air, how did it all start? Well, the 20th century is often called the century of flight. And this is because in the beginning of the 19th century, there were many pioneers. We'll have a close look at them. And of course, the first aircraft who carry a human in the air propelled by an engine, the Wright Flyer, is the one that kicked it all off. But it's also unbelievable, I think, that only 100 years later, when this was still considered something very hard at the beginning of the century, that we were already able to transport hundreds of passengers to the other side of the globe. And a lot obviously has happened in this 100 years. To get from the situation where it's very hard to get one person in the air to carry hundreds of passengers to the other side of the Earth. Let's have a look at what happened in this century of flight. It started actually already before the 20th century. Otto Lilienthal constructed his own hill in the vicinity of Berlin, and with his hang gliders jumped off and tried to investigate different airfoils and the basic principles of how to generate lift. He also crashed at some point when he got into a spin, and he got injured, and a day later he actually died. He generated a lot of data for the Wright brothers to use. And the Wright brothers started off with this and other data and building their own wind tunnel, and they were very much afraid that the same would happen to them as what happened to Otto Lilienthal. So they were very anxious to make sure that their aircraft were controllable, were sufficiently stable. And in Europe, people were even building aircraft so stable that it was impossible to make a turn. So there were a number of challenges set, and one of the challenges where the Wright brothers made a huge leap was to make an aircraft which was also agile, which could still turn, and was not too stable that it could only fly in a straight line. So this was the early pioneering phase, beginning of the 19th century. 1910, you saw many of those in Europe and the United States. And then what really accelerated the developments was the First World War. The military were among the first to adopt this new technology, first for reconnaissance, later also to drop bombs, initially with their hands, out of the airplane onto the troops on the ground. We see here biplanes, a row of biplanes, and this was a standard aircraft. It was easier to construct a biplane than a monoplane, and in this way they created a stiff structure, and of course they thought, well, two wings, you have perhaps twice as much lift, which is, by the way, not the case. All these aircraft were built for military purposes, and so at the end of the First World War, all these aircraft were there, while there was no war anymore. And this spurred the development of this aviation sector, so starting off with transporting mail, but also later passengers. The first airlines were created, initially using bombers and aircraft from the First World War. Also, there was some continued development in aerodynamics. For instance, we see in the biplanes, we see that the wings are relatively slim, but Mr. Fokker found out that when he tried a thick airfoil on his Fokker 7, as you can see here, it was possible to construct a monoplane which had very good aerodynamic properties. So not only was it easier to construct a stiff wing when the wing is thicker, in fact aerodynamically, for low speeds at least, is what we know now, this turned out to be quite a good idea. And this is a passenger aircraft developed not as a bomber but mainly to transport passengers, which were among the first uses of these aircraft outside wartime. Very rapidly after this interbellum, as the word says, there was of course the Second World War, and this again just increased the speed of innovation in aeronautics. The jet engine was an invention actually slightly before the Second World War. It was already in 1936. The jet engine was invented in Germany, and then the design of this aircraft was started. This is the Messerschmitt 262, the Schwalbe. It was a first jet fighter that reached operational status. The development started in 1936, but it was only operational in 1944. It was a huge leap in technology using this jet, which allowed fighters to fly faster and higher. And of course creating an enormous disbalance in the dogfights, in the air-to-air situation. This aircraft reached its operational status in 1944, and only in little numbers, and that's why it did not really affect the outcome of the Second World War. Had it been invented earlier, things might have been very, very differently. Of course, the development of faster and higher aircraft continued after the Second World War, mainly for the Cold War. The Allied forces were getting into a sort of competition in technology, in military technology, and one of the things that drove the development of aviation is the X-plane program. It started around 1946, 1947, and this is the Bell X-1, for instance, a rocket aircraft which shows how, which is the first aircraft to reach supersonic flight, to exceed Mach 1, fly faster than sound, controlled by the famous test pilot Chuck Yeager. This X-1 was the first of a whole range of X-planes. For instance, another famous one is the X-15, an aircraft which was the first one to exceed the 100-kilometer limit in altitude. And this is also seen as sort of the border of space. So this is in fact the first space plane. And the Cold War was not only something that took place in aeronautics, but extended into the space race in the 60s. And this aircraft was developed in 1963, hypersonic plane, very high altitudes, and prepared for hypersonic and for re-entry from space. The space race then continued, and of course the many technological innovations for astronautics are also used in aeronautics. Here we see the Apollo mission, the culmination of the space race. While initially the Soviets had a head start, in the end the manned mission to the moon was reached first by the Americans. And currently, to get into space, we are again dependent on the Soviets. So who the final winner of the space race is something you could debate. But in the same time, aeronautics continued. First with propeller aircraft, similar to the bombers in the Second World War. We had the Lockheed Constellation, for instance, but also this jet engine, which initially was invented for military jets to fly faster and higher, was then also used in civil aviation, also to fly faster and higher, but also because in terms of maintenance, it turned out that a jet engine was much simpler and had less costs, less replacement of parts, less moving parts than a piston engine. So the jet engine was also used for passenger transport in the Comet initially, and then later also in huge numbers in the 747. And flying became something that the general public could do. It started the mass consumption of aviation. There were more innovations. One by again a war, the Gulf War. The Gulf War spurred basically was the first war in which the stealth aircraft were operational. The F-117, famous for the bombing runs at Baghdad, was the first nearly invisible aircraft to be used in a war. And this also showed an aircraft in which another design goal sort of got highest priority. If you look at this aircraft aerodynamically, it doesn't look very aerodynamic. And this is because if you look at the disciplines, this is an example where one of the disciplines really got highest priority, in this case, the stealth aircraft. Beautiful story in the book Skunk Works by Ritchie, where you can read about the development of this aircraft. But also in civil aviation, we see now an urgency for ever lighter and more efficient aircraft. And this has spurred two main technological innovations in which the newer aircraft really differ from the older. Those are newer engine types, larger bypass engines, more efficient engines, but also new materials, construction materials. The fuselage of an A380 is made of a hybrid material, a fiber metal laminate. And here we see the Boeing 787, which goes even a step further. It's not made of metal, it's made of composites, plastics and reinforced by fibers. So there is still a lot of innovation ongoing, and this urgency for more fuel-efficient aircraft and also more environmentally friendly aircraft is something that's still ongoing and will have a huge impact on future aircraft. In our course, we are going to follow the history of flight. But this is not just the 20th century. In fact, flying is much older. If you look at the first flight, this happened by insects 300 million years ago. They were the first ones to fly. And of course later, birds. It's funny to see that even before the 20th century, when humans were trying to think of flying, that many argued it was impossible to fly with anything heavier than air, while in the same time, birds were already flying around, and they are heavier than air, and they are flying. So this is something that was because there was something that was a bit strange, but because the wish to fly is very old. People have wanted to fly from ancient times. We all know the story of Icarus, here depicted by a painter who wanted to fly, wanted to reach for the sun. This is something it's about hubris, but it's also about the wish to fly. And also in the medieval times, Leonardo da Vinci was someone that was inspired by these dreams. He made his paintings, his angels had much larger wings, which showed that he understands flying a bit better than this painter. But he also actually designed flying vehicles. He studied nature and then wanted to mimic nature with technology. And we see here, for instance, a primitive helicopter, which shows sort of air screw to lift off. Not this one, but some of his wings, his hang gliders, have been constructed afterwards and turned out indeed to be able to fly. So there were many pioneers studying it, but still we only achieved flying with an aircraft in the 20th century and a bit earlier with balloons. So why is this? Is it so hard to discover the basic principles to fly, to beat gravity? I would like to challenge you for the next clip. We will start with showing three physics principles how you can defy gravity, how you can fly. And I would like to challenge you to think, what are the three physical principles which allow us to fly, to take off from the Earth. I will get back on that in the next lecture and hope to see you there.